Okay, we are back, and with example 4, you will notice this one looks just a little different because we only have one fraction on the left-hand side. This is actually a proportion, and we usually solve those by cross multiplying, and you can. I'm still just going to practice our concept of finding that common denominator, so I'm going to come up here and we'll write our least common denominator. So we need x plus 1, and then we need 2x plus 1. So in order for our denominator on the left to look like our least common denominator, we're going to need a 2x plus 1, top and bottom. And then for our fraction on the right, that denominator needs an x plus 1, top and bottom. So now both denominators are the same, so we're ready to circle all the numerators, and then we'll write our equation. So on the left we have x minus 3 times 2x plus 1 equals, and then on the right we have 2x minus 3, sorry guys, times x plus 1. So whether you box, FOIL, distribute, we need to multiply both sides out. So I'm going to distribute, so we'll have x times 2x is 2x squared. And then x times 1 is x. Then negative 3 times 2x is negative 6x, and then negative 3 times 1 is negative 3. I'm going to do the same thing here, so 2x times x is 2x squared. 2x times 1 is 2x. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. So then let's combine like terms. So we're going to have 2x squared minus 5x minus 3 on the left, and then 2x squared minus x minus 3 on the right. Again, you have a quadratic, so you want to set this equal to 0. So I'm just going to do it the same steps I did before. So I'll subtract 2x squared. I'm going to add x. I'm going to add 3. So all of these are going to cancel out to give me that 0. And then our 2x squareds are also going to cancel out. So we actually have negative 4x. And then our 3's are also going to cancel. So you have negative 4x equals 0. So it's not a quadratic anymore. So we get x is 0 for our solution. So let's check our restrictions. Again, it's probably going to be easier if you go back up to your least common denominator since we had so much going on. So you know it could not be negative 1. And then this 2x plus 1 could not equal 0. So we would subtract that 1, divide by 2. So x could not be negative 1/2 as well. So this is not extraneous, and that would be the solution. We could check our work, guys, by substituting your solution back into your equation. You've done that your whole life. But the extraneous part and checking your restrictions keeps you from having to sub back in, especially when it's such a lot going on with all these rational equations, with fractions everywhere. But your turn if you want to pause the video and go ahead and try it yourself, and then start back and we'll check that solution. So I need to factor out a GCF on the right hand side of x, and then we can get our least common denominator. So we need an x, and we need an x plus 1. There's x again, x plus 1 again. So I need x plus 1 here. Here we need an x. And then this is our common denominator. So we're ready to circle all the numerators for your equation. So across the numerator we have 2 times x plus 1 plus x times x plus 2 equals negative 2. So I'm going to distribute as I go along. So that's 2x plus 2 plus x squared plus 2x equals negative 2. Then I'm going to combine like terms. So we have x squared, 2x and 2x gives us 4x. And then we have plus 2 equals negative 2. Quadratic, I'm going to set it equal to 0. So we're going to add 2. So that's going to give me x squared plus 4x plus 4 equals 0. And then I'm going to think about doing AC. So 1 times 4 is 4. I need factors of 4 that will add to 4. So that's going to be 2 and 2. We can use our shortcut. So then you know we would set each factor equal to 0 and solve. So we're going to get x equals negative 2. We would get the same solution there. So now let's look at our restrictions. So here x could not equal 0 and x could not equal negative 1. Our solution is neither of those restrictions, so it is an accurate solution. And that wraps up solving rational equations.